Let's walk through the technical architecture of SchemaWeaver. On the left, you see a Java FX-based thick client, which connects to all platform functional blocks using REST-based APIs. All requests are authenticated through Keycloak authentication service and routed via a Spring API gateway, acting as a single entry point to the platform. The core platform services in midsection, including back-end generation, front-end generation, data integration, shared modules, and AI Assist, are deployed as Docker-based microservices using a service discovery architecture. Each service manages its own configuration in a dedicated MongoDB schema. Data integration and shared capabilities rely on proven frameworks. The integration layer uses Apache Camel for integration and Apache Airflow for pipeline orchestration. Reporting is built using Jasper reports, while business rules are implemented using Drools. A separate Python-based ETL utility layer supports complex extraction and transformation tasks, leveraging a wide range of established Python libraries. For code generation, SchemaWeaver provides dedicated generators for front-end and back-end applications. The front-end generator uses TypeScript AST-based generation with TS-Morph and handlebars templates, producing Angular-based UI applications using PrimeNG components. The back-end generator produces Spring Boot applications, using structured Java code generation with Java Poet and template-based rendering. AI Assist is implemented as a dedicated service, integrating with ChatGPT SDK client libraries to support assisted configuration. On the right, you see the generated runtime artifacts, a front-end UI application and a back-end application, interacting through REST-based APIs. This architecture clearly separates configuration, generation, and runtime execution, while remaining extensible, consistent, and enterprise-ready. Right technology for functional unit. At the core, we use Java for our services, with strong Spring support, making it the best fit for robust back-end services. For the front-end web user interface, we rely on Angular and PrimeNG, giving us a component-based web UI and a rich, reusable UI library. For setup tooling, we use Java FX, which enables rich desktop-style tools and complex drag-and-drop designers for configuration and design. For data integration, Apache Camel provides strong integration patterns, along with routing and orchestration across systems. On the pipeline side, Airflow orchestrates data workflows and provides monitoring of pipeline runs, so data processes are visible and controlled. Business rules are handled by Drools, which allows us to externalize rule definitions and manage complex rule sets without changing core code. Reporting is powered by Jasper, giving us templated reports that are easy to print and export for business consumption. Finally, utilities are built in Python, leveraging a large library ecosystem and leaving space to grow future capabilities on top of this foundation. Schema-centric design means every layer is driven by explicit schemas rather than hard-coded logic. The backend uses them to generate entities and service layers, the UI uses them to render attributes as widgets and layouts, data integration uses them to move and transform data between stages, and shared services like workflow and rules operate directly on these schemas. The result is consistency by design, even when multiple schemas are involved. The platform is also extensible in terms of technology stack. From the same configuration, we can generate different outputs over time, such as React on the UI side or Python and Node.js on the backend, without changing the core model or architecture. The same extensibility lets us grow into unstructured data, NLP and machine learning. A Python-based utility layer can capture and process web content, documents and other unstructured sources, and apply NLP on top. On the ML side, we can define an ML dataset in a way very similar to a domain model, and then use existing data integration flows to populate training and test data. This keeps the design consistent while we add more intelligent capabilities around the core platform. Thank you for your time. We'd love to hear your feedback and thoughts in the comments.